For the next part of the chapter, let's move on to molecule. Now we have learned about atoms. Now let us learn about molecule and let us learn that how molecules are formed and how they are represented. A molecule can be defined as the smallest particle of an element or a compound that is capable of an independent existence and shows all the properties of that substance. Atoms of the same element or of different elements can join together by attractive forces to form molecules. Now what we are seeing here is that every compound, every element, okay, we know that they have atoms inside them, right? But do atoms exist independently? In the previous slides we had observed that mostly atoms, they do not exist in an independent state. They either form they either come together to form molecules with the same atoms of the same element or maybe of the different element. Okay, so when that happens, whenever atoms are coming together of maybe from the same element, maybe from the different elements, whenever atoms are coming together to form a combination of atoms, a combination of mass, we name them as molecule. And molecules, they are able to exist independently in a given element or in a given compound, and they show all the properties, be it physical or be it chemical, they show all the properties of that substance. So a molecule is that smallest, that smallest element. Let's just not call it element for the sake of confusion. A molecule is that smallest entity that is capable of existing independently in an element or in a compound, and it shows all the properties of that particular substance. Atoms of the same element or of different elements can join together by attractive forces to form molecules. Molecules of elements. The molecules of an element are constituted by the same types of atoms. Like I told you that they may be of different, of the same element or of the different element. So if the molecules of an element, they're constituted by the same types of atoms, how do we designate them? We designate them just by writing the symbol of that particular element. So for say argon, we just write Er. For helium, we will just write He. They are made up of only one atom of that element, but this is not the case with most of the non-metals. All right. So in some of the cases, there are exception that molecules are only form of one atom, but that is a very rare existence. Mostly atoms, they come together to form molecules. For example, a molecule of oxygen consists of two atoms of oxygen, O2, and hence it is known as a diatomic molecule. Why a diatomic molecule? Di means two. So two, we know from this symbol of oxygen that two atoms of oxygen are coming together to form one stable, independent, existing oxygen molecule. And since two of them are coming to form together, so we call oxygen as a diatomic molecule. So if three atoms of oxygen were to come together and unite into a molecule, instead of the usual two, we get a different compound, we get ozone. Okay, so in this picture here, when two atoms of molecule, they come together to form two atoms of oxygen, they come together to form a molecule, we get oxygen. But when when three atoms of oxygen, they come together, we do not get the usual oxygen in the air, or but we get a different compound altogether. We get ozone that exists in our atmosphere, and that protects us from the harmful rays of the sun. Atomicity. The number of atoms constituting one molecule of an element is known as its atomicity. So for example, we have oxygen. Oxygen is an element. Now the number of atoms constituting one molecule of this element, oxygen. We know that two atoms of oxygen come together to form one molecule. Alright. So two atoms are coming together to form one molecule of this element, oxygen. So we can say that the atomicity of oxygen is 2. Metals and some other elements such as carbon, they do not have a simple structure, but they consist of a very large and indefinite number of atoms bonded together. So for example, oxygen, in only oxygen, two atoms are coming together to form one molecule. There may be elements such as sulfur where 8 atoms come together to form one molecule of sulfur. Okay, so this is known as a polyatomic molecule. We'll learn about it in the next slide. Yes, here it is. Atomicity of some elements. Helium it is monoatomic, that is only one atom of helium can be said to constitute one molecule. Nitrogen is diatomic, two atoms of nitrogen come together to form one molecule. Phosphorus is tetraatomic, that is four atoms are coming together. And sulfur, like in the previous slide we saw, is a polyatomic molecule. 8 atoms of sulfur are coming together to form one molecule. Molecules of compounds. We saw that molecules of elements, how they exist together, but what about compounds, right? What we mean by compound, if you remember the previous chapter that we had learned, that when two or more elements, they come together and they form a chemical reaction, then a compound is formed. So in a compound, we have atoms existing from one element, and then we have atoms existing from another element, and they come together to form a molecule, to form a very stable state of molecule. Atoms of different elements join together in a definite proportion, the law of definite proportions that we had read earlier, to form molecules of compounds. For example, water is a compound where the combining elements is hydrogen and oxygen. So atoms of different elements, hydrogen and oxygen, are coming together, they are coming in combination to form this compound water, and the ratio by mass is 1:8. So every 1 gram of oxygen combines with 8 gram of oxygen, 1 gram of hydrogen, combines with 8 gram of oxygen to form water. Similarly, in the case of ammonia, that the formula of ammonia is NH3, where the combining elements is nitrogen and hydrogen. So in ammonia, the ratio by mass, for every 14 gram of nitrogen, 3 gram of hydrogen is coming together to form ammonia. In the case of carbon dioxide, where the combining elements are carbon and oxygen, the ratio of mass is 3:8, that is 3 gram of carbon for every 8 gram of oxygen. How to get ratio by number of atoms? The ratio by number of atoms for a water molecule can be found as follows. Now, in a water molecule, we know there are two elements, hydrogen and oxygen, and ratio by masses, for every 1 gram of hydrogen, we have 8 grams of oxygen. Okay, the atomic mass unit, or the U of hydrogen, is 1, and for oxygen is 60. Now, for very simple elements, you may have to remember the atomic mass units. Okay, so always remember that for hydrogen, the atomic mass unit is 1, and for oxygen, the atomic mass unit is 60. Mass ratio that we will get, we will divide the ratio by mass by the ratio of this atomic mass. Okay, so 1 by 1, and we are getting 1. The simplest ratio over here is 1. In oxygen, in the case of oxygen, when we are combining the ratio of mass by its atomic mass unit, we see that 8 ones are 8 and 8 twos are 16. So the simplest ratio is 1:2. So how do we determine that how many atoms of hydrogen come together to forms of how many atoms of oxygen to form one molecule of water? So the ratio that we get is 2:1, the ratio by which number of atoms for water they come together. So for every 1 atom of oxygen, we have 2 atoms of hydrogen. Okay, so this is how we get water. What is an ion? Now we learned about molecules, but what about ions? Compounds composed of metals and non-metals contain charged species. The charged species are known as ions. Ions may consist of a single charged atom or a group of atoms that have a net charge on them. Okay, so there are basically what is happening here is that every atom every atom seeks a state of stability. Okay, in the case of charged species, what happens is that a neutral atom may undergo some change or some condition where it may gain an electron or where it may lose an electron. Okay, so when an atom loses an electron, it becomes positively charged. Electron is negatively charged, right? So when there is a loss of an electron, that whole atom would gain a positive charge. Why would it gain a positive charge? That atom would gain a positive charge so that it will be at the lookout of one electron. And how will we get that electron? By an atom that has a negative charge. Okay, so what is happening here is that cation is that ion, is that atom that has lost an electron. Okay, as in It is in the way of seeking an electron in order to form its stable condition. An anion, on the other hand, is a peculiar case of charged ion that has an excess amount of electron in it. It may be one, it may be two, depending upon the particular anion, and that because it has an excess, so it wants to give away that electron. So what happens is that cation wants to seek an electron in order to achieve that neutral stance of stability, and anion wants to lose that electron in order to achieve that neutral stance of stability. So a chemical reaction forms between this cation and anion, where cation takes the electron from anion. So what happens? Cation gets the electron that it was seeking, the positive charge. What will happen to the positive charge? The positive charge will be removed, and the anion, when it will give the electron, that surplus electron, to the cation, it would also lose that negative charge. Okay, so this transaction of charges happen, and that is how ions are formed. Okay, and that is how they react with each other to form a stable molecule. Types of ions, like I was demonstrating you in the previous slide, an ion can be either negatively charged or positively charged. A negatively charged ion is called anion. It has a surplus of electron. Cation is a positively charged ion. It has, it is in the way to seek electron. It is at a loss of electrons. For example, sodium chloride, its constituent particles are positively charged sodium ions and negatively charged chloride ions. So the positively charged sodium ion, they want electron, they want to gain the electron, and the negatively charged chloride ions, they want to give out the electron in order to form a bond. So Na plus, that is the sodium, the positively charged cation, and chlorine, the anion, they come together, the transfer of electron take place, and then we get the stable compound, that stable molecule of the compound sodium chloride. A group of atoms carrying a charge is known as a polyatomic ion. Now this is one simple atom carrying a charge, right? There may be some groups of atoms that come together to form a charged species, and that group of atoms carrying charge is known as polyatomic ion. In this simple animation also, you are seeing that how the transfer of electron is taking place. All right. Writing chemical formulae. What is a chemical formula? Now, a chemical formula of a compound is a symbolic representation of its composition. The chemical formulae of different compounds can be written easily with the help of symbols and the combining capacity of the elements. So, a chemical formula of a compound is a symbolic representation of its composition. So, for example, we saw sodium chloride and we saw that how sodium chloride is formed. Okay, so this particular you may say sequence, all right, this sequence determines that how sodium chloride is formed. It is a symbolic representation of the composition of sodium chloride. Okay, so chemical formula, it can be written easily with the help of symbols. We are having symbols on this side. Okay, and this is the combining capacity. All right, we'll be learning about in the next slide, the very next slide. So this combining capacity determines that what will happen to what atom. Okay, and with the help of symbols we write the symbolic composition. Valency. The combining power or capacity of an element is known as its valency. Valency can be used to find out how the atom of an element will combine with the atom of another element to form a chemical compound. The valencies of some common ions are given. So again, like I told you, that a positive charge is determining that this element sodium, or this ion sodium, it has a combining capacity of 1. That means it needs 1 electron to be satiated and to reach that stable state. All right. Oxide, on the other hand, has 2 valency. So it has an excess of 2 electrons. Ammonium, that is represented by the symbol NH4, it has the valency of 1. Carbonate, that is represented by the symbol CO3, has it's a polyatomic ion. All right, you see here ammonium and carbon, they are polyatomic ion because they are groups of atoms, they are groups of nitrogen and hydrogen and carbon and oxygen. They are coming together, and they are coming together to form a charged species, an ion, where the valency of ammonium is 1 and the valency of carbonate is 2. Rules for writing a chemical formula. there are specific rules for writing the formula as well. Let's have a look. The valencies or charges in the ion, they must balance. Like I told you, the atoms, they are always in a state to find some stability, like we all are in life. So the atoms must come to that stable state. And how they'll come to a stable state? They will, an exchange of the extra charges will take place. Okay, the give and take of charges will take place, and that is how a balance will be maintained. When a compound consists of a metal and a non-metal, the name or symbol of the metal is written first. The name or the symbol of the metal is written first. For example, calcium oxide. So यहाँ पे calcium oxide. Okay, so calcium is a metal and oxide is a non-metal. So the rule for writing a chemical formula is that the name of the metal will always come first. Now one of the other has to come first, right? So it is the rule that the metal will come first, followed by the non-metal. Okay, so we have calcium oxide. Then similarly we have sodium chloride, where sodium is the metal and chloride is the non-metal, where oxygen and chlorine are non-metals and are written on the right, that is they are written after the symbol representing the metals are written. Okay, so calcium and sodium, since they are metals, they are written on the left hand side. Rules for writing chemical formula. Further we see that in compounds formed with polyatomic ions, the number of ions present in the compound is indicated by closing the formula of ion in a bracket and writing the number of ions outside the bracket. So here when magnesium hydroxide is formed, since magnesium has a +2 charge and hydroxide has a valency of 1, alright, so 2 atoms of hydroxide come together to form a compound with 1 atom of magnesium. Okay, so we have to write this, we have to write 2 for this hydroxide, right? So, and since it is a polyatomic ion, we enclose it with a bracket. So we write magnesium as Mg and we enclose the OH, we enclose the polyatomic ion in a bracket, and we write 2, we write that whole number, determining that constant proportion that would come together to form a compound with the given atom of magnesium. The simplest compounds, which are made up of 2 different elements, are called binary compounds. Now we are having a look at the formula of some simple compounds. We'll later move on to complex ones as well. So while writing the chemical formula of compounds, we must keep in mind that we write their constituent elements and their valencies. What will happen is that by writing their symbols, we are determining that yes, for example, hydrogen chloride, yes, hydrogen, for hydrogen we have the symbol H, for chlorine we have the symbol Cl. Then we have to write the valencies. Why valency? Writing valencies is important so that you may know that what sort of exchange is taking place. Okay, so we know that hydrogen has 1 valency, chlorine also has 1 valency. So this exchange is taking place here. All right, as you can also see over here, this exchange is taking place, and so what we observe here, that 1 atom of hydrogen comes together with 1 atom of chlorine to form 1 molecule of hydrogen chloride, or HCl. So we must write the crossover valencies of the combining elements, and that is how we get to the chemical formula of this compound. Other examples as magnesium chloride. So the valency of magnesium is +2. The charge that it has is 2. The valency of chlorine is 1. The charge it has is -1. So the formula would be that magnesium is taking that 1 extra electron from 2 of the chlorine atoms. Okay, so for 1 magnesium, so if magnesium is positively charged, okay, so 2 negative chlorine atoms would come together to form bond, and when this bond is formed, this positive charge will vanish, this negative, I'm sorry, this would be here, wait, this here would be a negative charge, this here would be a negative charge, this here would be a positive charge. So when bond is forming in between them, this magnesium, the positive charge is vanishing, the negative charge of both the chlorine atoms are vanishing. So when we write the valency with the charges, we observe that for chlorine, the crisscross is taking place. So for chlorine, we require 2 atoms to come together to combine with 1 atom of magnesium to form the compound magnesium chloride. That is why this writing of the valency and then crisscrossing them is important. So in magnesium chloride, there are 2 chloride ions, for each magnesium ion, and the positive and the negative charges must balance each other, and so that the overall structure must be neutral. Note that in the formula, the charges on the ions are not indicated. Yes, this is very important. When you are writing the final formula, there must be no charges written, alright? You just need to write the simple formula of magnesium chloride, that is MgCl2. Let's have a look at another example. For calcium oxide, we know for the calcium the charge is 2 plus, for the oxygen the charge is 2 minus. So only one atom of calcium will come together to form one atom of oxygen. We may write it here as Ca2O2, but you know that is self-explanatory, because this 2 and 2 will ultimately cancel, right? We can simply write this as CaO. For calcium hydroxide on the other side, since it is a polyatomic ion consisting of -1 charge, so here when this crisscross is taking place, two atoms of hydroxide would come together to form a molecule with one atom of calcium. Okay, so the formula of calcium hydroxide is CaOH2, where remember that the hydroxide, the polyatomic ion, is bracketed, and it's not written CaOH without brackets, but it's written OH2 with the brackets, and we use brackets when we have two or more of the same ions in the formula, especially for an polyatomic ion. Question 1. Write down the formula of sodium oxide. We know that sodium has a positive charge, and we know that oxide has a negative charge, that too of 2. Okay, so what is happening here, that this crisscross would take place, okay, and as a result we will be getting two atoms of sodium would come together to form a molecule with one atom of oxide. For aluminium chloride, here is aluminium, here is chloride. So we have aluminium 3 plus and we have chloride 1 minus. So again this exchange is taking place and we are getting AlCl3. Okay. Then for sodium sulfide, we have sodium. For sodium we have +1. For sulfide we have 2 minus, because the charge that sulfide has is 2 minus. So an exchange is taking place, and then we have two atoms of sodium coming together to form a molecule with one atom of sulfide. For the last one, magnesium hydroxide, we saw it in the previous slide that it has +2 charge. The hydroxide one has -1 charge. Exchange takes place, and what do we get? We get magnesium. One atom of magnesium would come together, and since hydroxide is a polyatomic ion, we write it within brackets OH2. Let's move on to the next question. Write down the names of compounds represented by the following formulae. This is aluminium sulfate, okay, because we are seeing here that aluminium has a +3 charge, sulfate has a -2 charge. So 2 atoms of aluminium coming together with 3 atoms of sulfate. Number 2 is calcium chloride. Here 1 atom of calcium is combining with 2 atoms of chloride to form one molecule of calcium chloride. In the third example, potassium sulfate. Since potassium has a +1 charge, whereas sulfate, as we can see in the first one, that sulfate has a -2 charge. So 2 atoms of potassium would come together to form a molecule with 1 atom of sulfate. In potassium nitrate, now this is a polyatomic ion. Nitrate, remember, is a polyatomic ion. But since for both potassium and nitrate the valency is only 1, we need not enclose the nitrate within bracket, and we can just write as potassium nitrate. For the last one, calcium carbonate, again there is no surplus of atom here coming together, because calcium has a positive 2 charge and carbonate has a -2 charge. So both of them come together to form calcium carbonate. What is meant by the term chemical formula? Chemical formula is again that representation of symbols, coming together to form compounds, and that is a very, a representation describing or, depicting basically the constituent composition of how that reaction is taking place. All right. So by chemical formula, we basically designate that how elements come together to form products and how the constituent elements are formed, how we designate them, how we depict them, how we represent them. That representation is what we get from the chemical formula. How many atoms are present in an H2S molecule and a PO4 minus ion? Now, over here, as we see that H2S molecule, we are having two atoms of hydrogen. Okay, so we are having two atoms of hydrogen that is coming together with one atom of sulfide. Okay, so all in all, we have three atoms. All right. Ion is a charged atom, you know that. Okay, so for phosphate, we will ignore this charge over here because we have to take account of atoms. We are not here calculating the valency. Okay, we do not have any we not have anything to do with the negative charge that phosphate is carrying over here, because we only have to calculate the number of atoms. So for a phosphate ion, we know that there is only one atom of phosphorus. Okay, and it is combining with four atoms of oxygen. Okay, so because this is happening, we have a total of 1 plus 4, that is 5 atoms. So we ignore the charge because we are here only counting the number of